everybody, and welcome to another E5 podcast. I am your host, Paul Meenan, and I'm joined again by both my tag team partners to finish off this extra bolt-on podcast to our series on the draft for public comment Amendment 2 of the wiring regulations. Chaps, introduce yourself.
Hello, I'm JW.
And it's David Watson here, SparkyNinja.
And we're not wearing the same clothes, and it's not the same day. And
no, not
yes,
at all.
It's another week. It's time is just but a distance we can't remember. We're going to go into part 8, and I have to say I thoroughly enjoyed this on the webinar, because at the end of it, literally brain was coming out of my ear. I had my brain melted, and it was just all over the place. So John, you're going to take the lead on this one for part 8, and we will stop you and ask you lots of questions if that's okay with you, as you are our part 8 connoisseur.
Yeah, well, we'll certainly answer what we can.
Can I just add that that's great, though, because if I'd have done part 8, it'd have taken 4 freaking hours. John's got this great way of just saying, "Oh, that's boring. That's not needed." I would have just gone through it all, and we would have just given up hope. So yeah. I'm really thankful for John actually covering part 8.
No, I think we've done. I think the webinars. I think they're one of the better things we've done as far as all the series of webinars we've done as a team. Still got more to go, but this is the podcast. So, John, let's get on to part 8. Functional requirements is its title.
Yep, part 8. This is totally new for BS 7671, and it's chapter 82 that we've actually got, which is prosumers low voltage electrical installations. And the reason it's chapter 82 is because they haven't bothered to give us chapter 81 or chapter 83.
But it's a thing, isn't it? I mean, chapter 81 is 60364-8-81. It's all there. You can pay for it now. You can pay for it and complete your 7671 set.
Yeah.
You know, if you wanted
to. Wasn't it in the 18th edition draft for public comment anyway?
It was. Yes, yeah. It was.
And they took it out and made it an abridged chapter.
They made it a British standard separate. Clearly, I think a lot of people in the industry wanted to push ahead with understanding and pushing technology into energy efficiency. I think they just didn't think 7671 was ready for it.
But it's still in the appendices, though.
Yes.
Yeah. Okay. So we've kind of got bits of it and not the whole thing. And then chapter 83, which is how to operate prosumers low voltage electrical installations, not included. So we've got what they are, but not how to use them.
Wonderful.
So, yeah.
Right.
Anyway, so yes, this covers the local production and storage of energy, and the term prosumer comes from producer and consumer of energy. At the moment, most properties are consumers of energy, but in the future, things like solar panels and other generation is going to be producing energy. And if you stick those two things together, you get pro and sumer. So prosumer. And this covers things like local battery storage as well. So you're taking energy from the grid in certain times, sticking it back into the grid at others, and maybe even running your whole installation separately from the grid in certain situations as well. So far more complex, and it's not just about energy going in a single direction. It's going in multiple directions depending on the exact setup you've got. Another concept which is introduced here is the smart grid, and this is where, rather than just here's some generation, here's a grid, here's your house or business, it's now far more complex and segregated down into individual units. So you've got generation, distribution now is going to be far more complex, and again it's going to be going into your businesses and homes, and crucially it can go back the other way. And the other thing that's there is now going to be two-way communication. Now, we've got some of this at the moment in the form of smart meters, but there's going to be a lot more of this, so that you can get information from the grid in terms of pricing and demand and this sort of thing. And crucially, you can send information back to the grid about your particular installation, how much load you've got and capacity and so on.
So, John, just on that, smart meters, they're kind of the early stages of what will be a smart grid, aren't they? They contribute in some way, don't they?
Yeah, it's the first bit that people are actually seeing and being in place to actually use. And at the moment, smart meters are basically being put in and doing pretty much nothing, other than you get a little fancy thing in your house that says you're using 200 watts at the moment, which is kind of meaningless, really. But the real value in those is that they're going to be able to provide your installation with data from the grid in a fairly near real-time basis. So every, say, 50 minutes or so, you can get new information from the grid saying the price has gone up to this horrendous level, and there might be a shortage of power here, or there's an excess, so you can have it for free, and all this kind of thing.
But that's the smart part of it, isn't it? It's that that two-way communication. If you're going to prosumers and the grid is becoming more, I think it's fair. We need to explain to people that in the traditional grid, it was always very linear, as we said in, I think it was the first podcast. Now the grids are having to adapt the DSOs to the smart grid, where they're getting large-scale generation, small-scale generation onto an old and aged network. And so it's fair to say that you may end up seeing regional networks all interconnected, swapping and producing and consuming energy, which is where the smart meters kick in.
Yeah, so all this rollout of smart meters at the moment is basically fairly meaningless in terms of the end user.
Yep.
The only thing you can do at the moment, there's one company that supplies electricity called Octopus Energy. They're the only company so far that has gone anywhere near this kind of facility. So you can have a thing with them where your price will update every half an hour, and then you can have equipment in your house or your business which will then take that pricing data and then determine whether you're going to switch certain things on or not, and what appliances are going to run, and whether you're going to charge your car, this kind of thing. So it's kind of there, but it's only just coming in that sort of end of things. And eventually it will lead to things like dynamic demand, so that if there is a shortage of power on the grid, certain things in your house may switch off. And that will be mainly driven by the price of electricity. So when the price goes up, you can turn certain things off automatically. And when the price goes down, you can switch them back on again.
So, I mean, is it just from the simple interpretation, is this is functional requirements, or what's it called? Functional requirements, functional part. Is this just like upgrading a home?
Yeah.
Is there another mean? Because I mean, I'm just thinking about when this comes in, and it's a new method, it's a new approach. This is going to be typically, the typical example of a new home, isn't it? Most likely.
Yeah, I mean, some of it. I mean, what you can do now, you can do some of this in your existing home if you want. So if you get an electric vehicle charger, you could set it up with that particular tariff from Octopus, so that it will only charge when the price goes below a certain amount.
So what I'm wondering is, if we can adapt our existing installations by rewiring them, modifying them, will this down the timeline become a codable thing if it's not applied, if it's not within the fundamental principles?
Well, that's a good point. It might do.
That's a good point. I think, Dave, you're going to have to wait until Amendment 1 is rewritten in either Amendment 3 or the 19th edition. But you're right. Once the fundamental principles get rewritten to include this smart grid and prosumerism, then I think definitely it's going to become a codable item.
Just while you've been introduced, I've just gone back in the thing in 1.2.3. It's not there yet. So obviously, if the fundamental principles get updated to include Part 8, then that's going to definitely be it's going to have to be something that we consider coding when there's an absence of application of Part 8. So I just thought I'd just talk about that now as we carry on listing of the wonderment that comes in with Part 8.
Yeah, I mean that could well be a thing. To say this, there's so much stuff in here that opens up all these doors to all this other stuff which doesn't, in many cases, exist yet. But yeah, that's a certain option. And this whole thing about smart grids is not some kind of future thing which is going to come around in a few years or 10 years time or whatever. All of this stuff is already being built.
But right now it's kind of like a gimmick or a thing for rich people or people who are being forced to have smart meters. We're able to choose right now, aren't we? We're able to purchase and invest in it or not right now.
Yeah, the smart meter thing at the moment is the sort of end consumer thing that you can see. But for the last several years, the actual grid itself has been changing in a lot of ways that most people don't see. So all of this stuff is already going in and is going to be a big thing. So don't think that this is some, say, future 5-10 years away kind of thing, because it's not.
This is just to take it just a quick step away. So I actually have a copy of IEC 60364-1, which is fundamental principles, and it was actually The draft for public comment, which is the one that I have, that closed in the 18th of January 2019 for comments.
Right, let's just add that you're saying this is the IEC, so this is the International
Electrotechnical. Yes.
So this is the high level.
Yes, very high level.
Coordinate under Senelec to then JPEL.
Yes.
So this is where we will see the first kind of changes.
So if you think of that date, which was 2018 closing date for comments, you can pretty much be sure that a year later, so beginning of 2019, that will have worked its way into the Senelec standards, which will then become a BSEN. That BSEN will then, you're probably looking for that to be brought in for JPEL consideration some point next year, probably later next year, I would assume. So I don't think the chapter 13, I'm going to say it now on this podcast, but I think fundamental principles will be rewritten for the 19th edition. I'm going to put a pound on.
So you've seen the public draft?
I've got the public draft of the IEC. I subscribe to all the public drafts.
Is there a tweak with the
fundamental principles? Well, part 8 is called design consideration. Okay. Which is one of the first changes, but there are little changes that stand out, like the good workmanship materials regulation requiring competence, which is just a beautiful thing.
So that tells us that it could be that in 5 or 6 years that we will be looking at opportunities to do this, because it won't be too far away by that point where maybe part 1 fundamental principles will have part 8 inclusive, and when it does become part of the fundamental principles, it has to then become codable observations, doesn't it?
I would suggest
if BS 7671 says to ensure the safety of persons, livestock, and property.
Well, in the new fundamental principles, it's the reg numbers are all completely different, sadly, but there is one regulation that says the installation of EEMS should be taken into consideration to facilitate the efficient use of electrical energy.
It then talks about management system.
Yes, local production and storage shall be utilised where available. It's a shall. So this standard is you can see it's 19th edition stuff. This is.
So if you want to stay in the domestic industry, you really can't choose to take this on. This is coming. Is that fair to say?
It's inevitable.
Without a doubt.
It will be arriving. And this smart grid thing, we're not going to cover it in massive detail here, but if you want to find any more information on it, just go to the Google or whoever, just search for ENA Smart Grid, which is Energy Network Association, and you will find a pile of stuff going back to 2017 and before. And it's all available mostly for free as well, so no need to get out the wallet on those ones. So that's smart grid. Now, in terms of Prosumer's electrical installations, which are the sort of set of equipment in your premises, so it's your generation, your storage, and of course the loads and things which are consuming energy in there. There's several modes in which you can operate this. First of which is island mode. This is something that's fairly new, and this is where your installation is disconnected from the grid, but crucially remains energized. So if the grid goes away for some reason, your house or business can stay powered, running from its own local storage and local generation. The second set of mode is connected modes, and there's 2 of these, and this is simply where your installation is connected to the grid. Similar to what we're doing now. There's 2 sort of subdivisions within that. You've got direct feeding mode, which is where the grid is supplying your installation with energy. That's basically what everybody's doing at the moment. Of course, you have to pay for that energy. And then the other one, which is relatively new, is reverse feeding mode, where your installation supplies energy to the grid. So it's basically going in the reverse direction. And the benefit of that one is that if you're supplying energy to the grid, you should be paid for that energy. So if you're selling the energy from your solar panels, or if you've got a load of battery storage that was charged up earlier, you can shove that energy back into the grid and be paid for it. And conversely, if you're not going to be paid for it, you could just use it yourself and switch into island mode and just run your house on it from things.
Yeah, again, I think the primary objective is to be able to sustain island mode for as long as possible, and then reverse feeding would probably be your bonus if you have enough stored.
Yeah. The benefit of reverse feeding mode is that if there was a shortage of power on the grid, then if there's a lot of installations with excess power available, they can feed that back into the grid and keep the rest of the grid working. So even if it's people that don't have all this stuff, they just got a normal consumer installation, they can actually still stay on thanks to the benefits of other people putting energy back in. So it gets quite complicated in that situation.
So, chaps, just going back to let's take a step into the future of the future. In this 60364 Part 1, there is a new diagram in
this is IEC 60364.
This is IEC, and it now diagrams a TNC system.
What, outside of a building? Not inside the building, surely.
Inside the building.
Oh, really?
Right.
By RCDs?
No, it literally just says TNC with neutral protective conductors combined in single conductor throughout the system. And this reminds me of, I was reading, call me sad, the Canadian wiring regulations, the latest version, which was released a couple of months ago. They have ditched the neutral conductor completely. They just now call it a grounding conductor.
So it's like is it a constant pen?
It's a constant pen, yeah, basically. So all that return current is grounded. That's it. That's what they've gone to now.
So the GFCIs work though with that?
I have no idea. I'm not Canadian. It's a weird system.
There'll be problems with that because the whole concept of them is that it's
I was reading it for fun. Yeah, guys, come on. It was just to take my mind off our
that's
mess.
Another Pandora's box of dubbins that's just opened up.
It's interesting, no, but the thing is what it is for those listening or watching, if you want to know where the future of things are going, just take a rough sample of New Zealand or Australia or Canada or America, where they've released new regs. Ireland's just released new regulations, just to see the subtle differences for the systems. But this TNC system, it's not in our regulations at all, but it is in this. So maybe when we were talking in the last podcast about functional earthing being hidden or dressed, and maybe there is this merit of, because these devices we were talking about, where in the event of a broken pen, if it does link functionally the neutral and earth together to allow an RCD to work, that's a TNC system, surely.
If we end up with if we end up with devices that go back to VOE-LCVs, where we have voltage operated devices, that I can see that leading the win for pen conductors, because obviously you're not no more RCDs in that case. Interesting, but we have digressed.
Sorry.
This is just an example of our typical chats.
Yeah.
Let's push on.
So, 3 modes then. So island mode, direct feeding mode, where it comes in, and reverse, where you're sending energy back to the grid. And the crucial thing with this is that switching between these modes could be a common thing, as in several times a day, and it should all happen automatically depending on the particular conditions at the time. So,
and is the optimal condition here your stored power or the requirement of the DSO, do you think?
What's probably be down to the individual installation, because ultimately you want your lights to stay on. And if
so you can have like a little switch saying I hate the DSO or I like the DSO.
Yeah.
Or I like my power or I don't want my power, kind of thing.
Yeah. So there's a lot of choices involved. It's, in theory, you want to make sure everybody has power all the time, but ultimately a bit of selfishness is going to come in there. So that
if it comes to island, there's going to be a lot of selfishness.
Yeah. So if you've got all the batteries in the storage, well, your lights stay on. So now, in terms of having all of this stuff in your particular building, which is going to be your storage units, as in batteries, generation, most likely going to be solar, wind possibly, and of course loads, there's 3 different arrangements of these things. So 3 types of prosumer electrical installation. First of which is called individual. This is by far the simplest one to understand. It's simply a single building. In the building you've got loads, you've got generation, probably solar panels, and you've got your storage, most likely going to be batteries. Batteries could also be in an electric vehicle, or they could be fixed ones, say just installed in the basement or whatever. And that building also has a connection to the grid. So it's just a single unit with those things all contained within. The second type is called a collective. This is where you've got a set of buildings or dwellings or offices or whatever else, all with loads in. So basically a standard installation. And then your generation and storage are in a separate part of the building or a separate location. And that single set of those things is then shared between the other loads. And the most obvious one here will be a block of flats. So you've got, like, say, 20 flats in the block. big pile of solar panels on the roof, storage batteries or electric vehicles in the basement, and although there's only a single installation of the batteries and the solar panels, it's then used for the benefit of the whole block.
So this interests me. I mean, if you've got a block with an array, if you've got a block of apartments with an array on the rooftop, do you have some kind of strategy to make sure you give equal offerings of the stored energy to each dwelling or domestic, or is it a case of first come, first serve for the stored energy?
Well, it should be set up so it's for the benefit of everybody.
Mm.
And that comes in later with another lovely definition we'll cover later on. And the collector, of course, is where you have your Borg cube flying in, and that's actually the energy storage and the generation. And then the individual units are the individual drones from that, which we covered in the webinar previously. And then the third one is called shared. So this is simply where you've got multiple units which have all got generation in them, storage in them, or a combination of both. And they're just working together to share their resources among themselves. So they could be, say, row of houses, they've all got solar on the roof, some have got batteries in them, some have got electric vehicles, and then they've chosen under the management equipment which is installed to manage all of that and share the resources between themselves for everybody's benefit. And all of these have a connection to the grid or the public network. Where that point is can vary depending on how it's been set up. You could have it set up so that, say, the block of flats, the public network connection was at the entrance to the entire block, which will then give you the interesting option of changing the entire block of flats to run in island mode with its own generation and everything. Or you could have the public network going into individual units, which then unfortunately would preclude the option of running in island mode, but you could still share the power and generation amongst them.
I could definitely see if you have like flats where when you're going to island mode, there'd definitely be some priority for the landlord lighting and things like that to have supply first, I think, over some of the individual dwellings. It depends on the efficiency of the storage. What do you think is the when we talk about generation here, we're mentioning solar, but there's other things, obviously ground source, there's wind. Do we think that this technology is going to also evolve with this, where we may find that homes in 10, 15 years will have wind farm as a standard installed within their bricks or within their structure, or maybe even ground source in the garden? Do you think?
I don't think wind is going to be a big thing, certainly domestically, because the problem with wind is that you need a decent amount of consistent wind in basically one direction. And as soon as you've got a load of buildings around, you get gusts going all over the place, and it's horribly inefficient and doesn't work. So, although it's
maybe if you're out in the middle of nowhere,
if you've got some remote farmhouse on a hill somewhere, then certainly by all means put the wind in. But certainly in an urban environment, wind doesn't really work because of all the various buildings around. And even if there's not that many buildings, as soon as someone's put up a wind turbine, that actually affects the wind patterns as well. So then somebody else can't have one because it's now damaged the.
It's the same principle of solar and shading, isn't it? When you shade over your solar panels.
So although it's possible, in reality, it's most likely going to be solar, because solar can be fitted pretty much anywhere if you've got a roof or a car park or a garage roof or whatever.
Just a silly question here. You're going to get roads, cul-de-sacs, whatever, buildings where they slowly start to develop this, on-site generation, storage, etc. Is an electrical installer is there any merit to when you're going into a home that's phasing its way on that journey to being a full-blown prosumer, to knocking on the houses around him and saying, what have you got on your electrical installation? Because there is kind of references to shared bonding and shared foundation electrodes within this draft for public comment. Is it going to be a point where we need to know what's going on the smart grid locally?
It could be.
I think
it's going to be a weird one.
I think the way some of it's written with island mode, it kind of makes us all feel selfish and want to have our own little provisions. But I think that for the most sustainable solution, there would have to be something like that, Paul.
There is a video on YouTube from the Energy Network Association about this particular topic, and although it's quite brief and short, within that it does hint at saying having a set of houses which then collectively together can become basically a miniature power station. It's only covered very briefly, but that is certainly something that seems to be in the thinking of it.
I should imagine with regards to things like efficiency and losses, it'd be better if things were connected as one.
Yeah, it certainly would. So it's all, the more you look into this, the more and more possibilities of how this could work sort of just come to the fore there. So
yeah.
Now that brings on to a definition here, which is the EEMS, which is Electrical Energy Management System. And this is kind of the equipment which links all this together and communicates between all of those elements of generation, storage, and loads, and all the rest of it, and then makes some kind of intelligent decisions as to what's going to be turned on, what's going where, what modes we're operating in, and all of that. So it's not particularly well defined in the draft there, but essentially this is just going to be either a single bit of equipment that connects to everything, or more likely it's going to be individual pieces of equipment that communicate together in some way to determine whether things switch on or not and what loads are used and so on. And
we're seeing some of this already with some of the electric vehicle charging points, aren't we? They've got like Zappi have this software where you can look on your phone, you can actually look at how much power you have utilized and how much of that has been from your solar, how much of that has come from your vehicle or come, back to your vehicle. It's there. It's just a case of, we have to be some central program or some central thing that talks about to all of these together.
Yeah, it's the parts of it are kind of there. That is definitely part of electric energy management system, those chargers. And so that tariff from that energy company, their system works through the if this, then that system. So it all links into that, and then you can set it up so that if the price goes below 8 pence, we want to charge our car, and if it goes above 14 pence, we want to switch certain things off, and you can actually get that now. So it's most likely going to end up being a whole set of various bits of equipment and machinery and things which all link together via some common interface to determine when things happen, rather than some massive sort of box of stuff you just plug into your house and it does all the stuff for you.
Yeah, I mean, you may think of it as like a big box of brains, but it's just going to be magical software that you pretty much just program on each device, I would suspect.
Yeah. And it will all connect to the internet and all kinds of other stuff and communicate in various ways. And
yeah, we're going to need to understand cybersecurity, gateways, smart tech, domestic. Do you know what I've always said? Those who mock the domestic walk a mile in their shoes. Now, domestic is going to be the front line of complexity. It's already there, to be honest, when you go into smart home, but this is just going to force it into that. You need to know what your onions are. Unless you're doing a basic radials, RCD system, anything other than that, boom, you better know your stuff.
Yeah. And the interesting thing about this, because all this stuff will require the internet to work, having an internet connection in your house is going to be an essential thing.
Absolutely essential.
Because as soon as that goes away, none of this stuff is going to work.
Yeah, that's a worry.
So you might even see things like if you've got, say, a cabled or wired connection to your house, you might need to think about putting in, say, a backup 4G or 5G internet connection, so that if the wires go down or someone chops through them, it can still make that connection and actually still all this equipment can still operate.
Whew. I ain't got the money for any of that, so I'm okay.
So that's electric energy management system, more likely to be, say, a set of different bits of stuff which all link together. So some of which we've already got.
It's fair to say that some smart kit now comes with that built into it.
That's
as well,
the point.
It?
I mean,
like the Tesla Powerwall and.
Yeah, this is going to have, it's open now till December. It's then going to have a year. It's then going to be released in 2022 potentially. It's then going to be applicable from 2023. That's the current timeline. But that doesn't mean right now we can't look at these new manufacturers' innovations and relate them to this.
Yeah, and I hope the manufacturers as well really start putting some efforts into offering some introductory free CPD learning to take people on that journey, regardless of what level or layer they're at on their journey, because it's going to take it. It's fair to say my brain's melted.
It's exciting though. It's exciting that there's new things to learn. There's new skills to develop. I have a concern about the way they will be trained. I'm definitely going to go and check out the guys who actually are trying to set a good standard. You mentioned on a previous thing the Arts of Smart Chaps. When contractors, electricians decide themselves to try to teach their skills, that, I need to check them out, but that's great.
I followed them on Instagram a while ago, and I've messaged them because I have seen nothing but mind-blowing amazingness from them. Their corporate behaviours, their support structure, the way their head office has been built with tender loving care, the training, the support they're giving their guys, the people who are doing Art Smart, I've got nothing but good things to say. They are projecting a fantastic business model.
But for me as a trainer, I've got nothing but experience with old trainers, old tutors that don't want to learn, don't want to rehearse, don't want to practice these skills. And then I look at companies like that that want people to work to their level.
Do you know what? I would love to go on one of their courses, but I'd be scared to fail it because it looks so outside of my comfort zone. And the weird part of me wants to do it because I want to push myself out of my comfort zone. I don't want to sit in that box of, I'm just going to do lights and switches and sockets.
Just do it for fun. That's what I do.
Do it for fun. Yeah, no, yeah. It'd probably be quite expensive to do it for fun.
But yes, it would be. But that's it.
But I would like to do it.
But other people as well. We need to look at other people who are doing that. But that's just smart homes. There's a lot more to this than that. The smart home angle is part of this, but there's a lot more. And I think they're going to have to go on a learning journey themselves with this.
Yeah.
Yeah.
So I
all
think it's
this
fair
stuff,
to say those. Sorry, John.
Link together. Yeah, all this stuff like smart home stuff, it's all going to link together.
Yeah.
A bigger picture of stuff. So a lot of this stuff is already existing. It's just sort of adding more and more stuff into it as more things are introduced.
Mm-hmm.
So that kind of brings us on to technical issues, which is actually what they've called.
I love that name.
Does that say refer to whole book?
Section 826. Technical issues. It's just almost as good as when we found that word basically in the other standard pool.
Basically?
It's just technical issues. Yeah.
So this is, we'll cover these fairly briefly there, but this is the whole set of things to consider basically for installations that operate in different modes. And one of the key points here is that if you've got different modes, so you've got power coming in from your batteries and your solar panels and from the grid, possibly a combination of all three, you've got energy going in different directions than it normally would. So one of the first consideration is that if you've got protection in your installation against electric shock, that protection has to be effective in all of the modes that installation can operate in.
Yeah, because obviously we have to achieve significant impedances, significant fault currents within certain disconnection times. If we're going to still use that method.
Yeah, and certainly things like impedances. If you've got a grid connection, it's going to have a very low impedance. But if you say change to your storage batteries and an inverter, completely different characteristics. So you need to make sure that whatever protection you've installed is actually going to work.
There's a regulation like that in section chapter 55, other equipment with low voltage generating sets, where it says, if we have a system that's on a temporary or an alternative, they have to have protection in both cases, and that's what this is.
So now you've just flicked the switch on my rant mode. This is the 16th edition thing that got my hairs on the back of my neck standing. Yeah, what this means, again, this is my interpretation of this. So as a standard Spark getting in the van every single day, these protection against these technical issues with prosumers, operating modes can change at any time. So I could have a TNCS earthing system with I go in, I'm doing some work, I'm converting it to a prosumering, 2 Tesla walls, a EEMS connected to the internet with, as you said, 5G redundancy, a smart home, the whole kit and caboodle with controls and all sorts, remote app access, the whole. Now, I may now have to realize that my electrical installation on TNCS, my earthing and bonding must be compliant, and my disconnection of supply must meet my ADS and any other protection measure required for normal operation. But the minute I switch into island mode, I then need to consider what is my method of protection and earthing. What is the level of fault current that I need to deliver to trip my breakers to meet my ADS? Is there any additional bonding requirements that I need to consider? Because we're now dealing with DC battery sets, functional earthing within the equipment, and obviously any potential overwhelming of DC sources of my protective devices. So it's a real backwards forwards mind screw of a selection and erection. But
and the other part of this is current goes in different ways, and
Yes.
also the reporting would have to have numerous sources of supply, and those numerous sources of supply would have to have each circuit's values verified for different sources. So you have one circuit that might have 1, 2, or 3 sources of supply. You should really verify that they are adequate for each source of supply. But then, obviously, the example in Chapter 55 is a scenario where we switch as an alternative or as a standby supply. But as John has said, this switching can happen multiple times in a day. You know, so it's going to be interesting.
Yeah, the scope of this section actually specifically excludes things like standby generators, which of course already exist. Something
which is why UPS systems don't come under this.
Yeah, so they're the sort of thing you might use, say, once a year when there was a power cut, or more likely when you're going to test the thing to see if it still works. But this kind of thing is going to be switched in and out all the time, potentially hundreds of times a month, thousands of times a year. So protection has to work in all the modes, and if you're changing from one mode to the other, the earthing type might change. So you may end up with a TT system or an IT system. And it's actually suggested in 82611 that you might need 2 devices for fault protection.
I can see IT systems becoming more popular because in theory, an IT system, the first fault goes to your local method of earthing, doesn't it? So in theory, if I'm switching out the DNO, am I TTing that installation or am I ITing it?
But that's going to have monitoring or something, which would then have to have some increased understanding by the homeowner.
Yeah, the
good luck
monitoring.
with that.
The monitoring of it, I mean, for IT systems particularly, you want monitoring to detect at least the first fault. But you don't want to rely on having the second fault.
I mean, once an IT system's gone to its first fault state, it now requires quite a significant amount of current for the second fault due to that higher impedance in that earth. But it doesn't really want to operate under a second fault. The idea is there's a monitoring system that will tell the person babysitting the IT system to come and action on that. But it's interesting. I can see, I mean, you mentioned here modes. I can see maybe an EIC in the future having every circuit would have modes of supply, and maybe mode A, mode B, mode C. You then reference mode A as the maybe the consumed supply, mode B this supply or whatever, and then you'd actually have to then always have verification of the circuit conditions on those different modes.
Yeah,
there's got to be a way to simplify this for people.
Certainly possible.
Yeah.
And if you look at 82612, which is protecting its overcurrent, it actually states that short circuit current at all points of the prosumer's electric installation will be taken into account, and things like direction of the current and the polarity, combinations of power supplies connected, because you could have batteries and solar coming in at the same time.
But John, this links to the addition in part 6 of the where it says earth loop impedance and prospective fault current.
Yeah, that's it. And also the location of the fault. Location of fault relative to where the supply is coming in, because in a traditional installation you're always thinking about the origin is at a certain point and that's where all the energy comes in, but once you've got multiple supplies, that origin may be in a different place depending on what mode you're in and where you're connected to.
Yeah, no, I don't disagree.
Is there anything added to Part 8 with regards to testing schedules? Or is there anything you guys have covered?
There was nothing in Part 6. There was nothing in Part 6 that was a forward reg number. So I think
nothing referenced to short circuit current.
No, and I think I think Part 8, one of the pieces of feedback is a lot of other parts of regulations may have to have a forward-looking regulation as well. So Part 6 definitely.
Part 6 definitely.
I can't see this not coming in without a new or an additional EICR form, schedule of circuit details, means of earthing. I mean, online softwares like Electroform, they'll fly through this. This will be a walk in the park for them. They've probably already got something similar to this anyway. But the wiring regs is so behind in its level of detail, it's mind blowing.
Yeah, the model forms don't cover any of this in any way at all. Which fairly major.
I mean, that's gonna have to be. There's gonna have to be some form.
Yeah, definitely. I mean, if you go to an installation that's got storage batteries, what tests are you going to do on it, and how are you going to record them?
So in that regards, chaps, would there be then another draft for public comment, given the fact that you could use that argument, and it's a valid argument, to say that this is an incomplete draft for public comment?
Well, either that or they're going to have to retract this. It's not because we haven't got any way of reporting this stuff.
Well, if this appears in Amendment 2 and it doesn't have the model forms, then it's an incomplete standard, you could argue, because there's insufficient guidance being given. So if they retracted it, they'd have to go through the whole process again. So it'd be very interesting to see whether or not they get so much feedback on Part 8, they do what they did on the 18th, which is withdraw all of Part 8, having had 2 rounds of feedback, to try and spend more time making it a complete standard. Yeah. Which would then fall in line with the design requirements of 60364 Part 8, Part 1, and then they could release all of the parts together and update all of the relevant sections in the more. This is a 19th edition.
That'd be the 19th though. Then
this is going to be the biggest. 19th will be the biggest rewrite in the regs for decades.
It will be the 19th edition Volume 1 and the 19th edition Volume 2,
as we predicted. Yeah, parts 1 to 6, and then 7 and 8 will be separate, or maybe 1 to 5 and 6 to 8.
It'll be a 3-day course and 45 questions, multiple guess.
Hopefully not.
Yes, right. I think the era of the 3-day course is well, with all this, it's gone away, hasn't it? Because you couldn't fit all this Part 8 in 3 days. So.
If the industry does that, then people like me and the other guys I know will just have an alternative.
Yeah,
you have to. Yeah.
So,
right. Sorry, John. Where were you?
Next consideration is outage of the public network. So the public network goes away. What are you going to do in your installation? Are you going to switch to island mode and run everything, or are you going to do what solar installations do at the moment, which is just disconnect everything and not have any power at all? So that choice is still there. Realistically, I can't see anybody going for the disconnecting everything, because if you've got storage and generation, why wouldn't you want to use it?
Well, I mean, this is the whole point of Prosumer fundamentally, is to kind of support the network with its, and part of that support procedure is for us to not rely 100% upon its integrity.
So you'd certainly want the island mode option
just to give it, just to give them the odd little pat on the back when they break down.
Next thing we've seen this in other parts previously, is transient over voltages, because if you're switching between all these different modes and switching in storage batteries and solar generation, disconnecting loads so there's too much load on the grid or whatever, all of these things are going to create transient over voltages. So of course surge protection is required on prosumer installations. Just
imagine you're in a local cul-de-sac and everybody's prosumering the switching transients you're going to get on and off, island mode, non-island mode, island mode, non-island mode, depending on where the bungalow is in the air in the cul-de-sac. It's a lot more switching going to be happening, isn't there?
Imagine the mess that the actual grid's going to look like with all that going on.
Well, that's what G55 is about. It's trying to sort that mess out. It's site specific, not installation specific. So it'd be really interesting to see how that develops in its understanding in the industry.
And then once you add in heat pumps with inverter compressors and all the rest of it switching in and out all the time.
Yeah.
Oh gosh.
It's just imagine that.
And the thing is, a lot of electricians still today are kind of not moaning, they're frustrated because they still believe that the boards we're gonna have boards this size, the size they are now, and I just can't realistically see how any of this is going to work until we just understand that we need to go more like the boards in Europe.
Yeah, we're going to have bigger boards. Yeah. We've said that since the 18th, bigger boards.
And the thing is, if we, and this is the thing, if you're thinking about commenting and objecting to these because you don't want the size of boards to change, it really isn't going to get you anywhere.
Nope.
No, they're going to get much bigger, because bearing in mind all these switching devices and all the additional protection for all the different modes and everything, it's got to go into something, and it's not going to fit into a 6-way Wirex board of about sort of 8 inches across, is it? So fairly obvious. So.
But it's the thing. I mean, if you're rewiring a board, if you're going to do a rewire today, don't put the board where it is. Rewire the system and find a new position to allow that board to increase.
This is what I've done on every rewire I've done for the last 10 years. Find a new position for the board.
If they've got their board under the stairs, move it into that spare room.
Yep.
On a wall. So it can be upgraded in 5 to 10 years.
The last one I did was in a dining room. It was at head heights. It was nice to work on, and then it was just partitioned with a discrete MDF boxing around it with a set of magnets. You could open it up. There was all the trunk in the board, nice and accessible, armoured, straight from a double pole isolator. Job done.
Yeah.
Exactly.
If we're going to carry on just changing skeleton frame for skeleton frame under the squeezing in, yeah, cost is the reason, but it's an optimal time right now if you're rewiring a home to reposition that point of distribution if you can.
Yeah. And if you're fitting a new kitchen, do not put the kitchen over the top if you can see it. We've all seen that.
Yeah.
So, yeah.
Moving
And if you're doing that, you might as well have the actual DNO connection, or DSO, as it's now going to be, moved outside into a cupboard rather than it being stuck inside your house.
Yeah, they won't give you a new one inside anymore, will they? They'll always put it outside now.
So I'm doing it on my house. I'm getting the gas and the cable moved.
And to be fair, who would want it in their house knowing what can happen to them? Especially when they're the black phenolic varieties, of course. So.
I was going to say, get out of my house. It's an understatement.
So, the next one is interaction with the public network. The Prosumer electric installation needs to comply with the supplier requirements in terms of things like voltage and frequency and harmonics and all the other stuff. And there's an annex in there, but basically it says go and look at the Decode website, which is decode.org.uk. And fortunately, that is free to access. So everything on it can be seen free by anybody.
Fantastic.
863 is energy storage, which is basically about considering inrush current from things like batteries and other capabilities, which hasn't actually been defined when switching between modes. Characteristics of the batteries might be.
I'm assuming these switchovers are supposed to be non-delay. Is that correct? You know, if you think about if we think about what's it called, classification, where we switch over to an alternative. The idea of this is there's going to be no delay. It's going to be basically you won't even really notice.
Static switching, basically, isn't it?
Yeah, seamless, because if there was like a 5-second delay when your power goes off, that's not going to help anybody, is it?
No, especially
the inrush should be massive. You drop off and drop back in.
Who wants to go on the house resetting the oven every 10 minutes because the mode changed or something?
Yeah, it's true.
Yeah, so you would hope that switching between modes would be fairly seamless and you wouldn't actually notice. And I think the whole point is that it's most of the time it's going to be automatic. You don't have to do anything. It's just installed, set up initially, and then pretty much runs itself based on the data that comes in.
It's going to be a clever switch, though, because it's obviously not going to feed back and it's going to switch so many times a day.
Yeah.
That's,
and it's going to have to be pretty durable as well. Got to be designed for that, and of course if it's not, you can't just have like a traditional standby transfer switch because that's designed to work once a year. But if this is going to be switching on and off, say 10 times a day, it's going to have to be designed for that. And this actually refers to 603.64.8-1, which is the part that's not included.
Oh yes, the energy efficiency part, isn't it?
Yeah. So why don't you just put it in there? That would make it much easier for everybody, wouldn't it? Rather than just putting it into the refer to some other standard. Electric vehicle charging is mentioned here mainly for the fact that electric vehicles are both a load and a storage device. So you, of course, can charge your car, and then potential car can then power your installation if needed. And of course, cars not permanently connected to the system, and again should be managed by the electrical energy management system, which we're already seeing now with the smart charger units.
And this isn't anything new. I mean, I remember when we first had a mention of 722. That when I first started to look at electric vehicles, they used terms like scraping, and then they obviously changed it to other terms. But it's always said that there's a consideration, or it's under consideration for the idea of the vehicle to feed back. It's always been there. There's always been a mention. It's under consideration. So we've now got to that point.
Yeah, and having your car supply a house is completely viable. I'd say your typical house in the UK, daily energy consumption on electricity is about 10 units or 10 kilowatt hours. And if you look at, say, a Nissan Leaf, which is a fairly low-end electric vehicle, it has a 40 kilowatt hour battery. So if you run your average house for a full day off of your electric car, you've only used about 25% of its charge, meaning you've still got 100 miles plus left in it to go driving somewhere. So the amount of energy stored in an electric vehicle compared to what you use in your house is absolutely massive.
Who knows? We may even end up with a point where the EEMS will actually go, oh, okay, you're now on your vehicle, and they might even then say to the circuits, you're now on vehicle mode, and so some of your circuits might even try to allow or adjust what they pull or how they operate, like your lighting, etc. For the sake of your battery.
Yeah.
But it should. I mean, again, 40 kilowatt hours should be more than adequate for a day of use.
Yeah. And so that's a Nissan Leaf, which in the scheme of things is a fairly low capacity vehicle now. Once you get into things like the Teslas with the 100 kilowatt hour plus batteries, there is a massive amount of energy stored in there. And this is where the vehicle's a good thing, where your vehicle feeds back into the grid to support it. It's not the deal where you come out in the morning, your car's battery's flat and you can't drive to work. You're only going to take a relatively small amount out of it, which in driving terms might only be like 10 miles. But if you had a lot of vehicles on the system, say 500,000 or something, collectively, that's a huge amount of power. And you're talking about the same power that comes out of a typical power station.
I guess this is the thing, though. A lot of homeowners and even some electricians they'll just assume that they'll just think of that dead battery in the morning.
Yeah.
Well, that's the problem with electric vehicles. There isn't a high level of confidence with electric vehicles. I know a lot of people who would love one, but won't buy one because they have zero confidence in them. Hybrids are a different thing.
See, I had the same though, because I work around the UK and I had a hybrid, but the problem with that is I would charge it up and I'd only get down the local A road of mine to the M1. By the time I'm on that, it's gone, and I'd then be because it would be charging with the brakes, and I'd then have to fill the petrol because it didn't have enough batteries in it.
The main reason that hybrids exist. The main reason that hybrids exist is so that certain manufacturers of vehicles can continue selling petrol engines to people, because they've got these massive engine plants, they've invested billions in them, they don't want to close them down just yet. So a hybrid is a way for manufacturers to keep flogging petrol engines and at the same time saying, oh, actually, it's got this little electric motor in which can do 50 miles and somehow save the environment. So
yeah, no, it was my company gave it to me. And for town driving, I think it was all right, but I never.
Oh, there's my dream of a hybrid. Looks like it's back to transits then. Okay, fair enough.
So we could discuss electric vehicles in another podcast if you wanted, but
I think
we're not going to do that today. So
no.
So we should move on to
what's the next technical issue, John?
The next technical issue is 8266, which is selectivity, privacy discrimination.
Right.
And this is a principal way if you have, say, fuse, 3-amp fuse. You don't want that to obviously you don't want that to fail first. You don't want your 63-amp circuit breaker or something to fail before that. Fairly well established principle. The problem with the prosumer's electric installation is you've got to think about where the energy is now coming from. So it's not just a question of here's your fuse, here's the circuit breaker, and that's the direction the energy goes, because if the energy starts going in another direction, you may find that your protected devices aren't in the right order anymore. So you've got to consider selectivity again in all of the operating modes and make sure that it is actually going to work in the ways that you think it does.
So how would that work? Would they use diodes to switch it from one device to the next, or what would you do?
Yeah,
not defined.
No, like a lot of this stuff, it's described, but there's no actual.
They've clearly got they've got to direct the current in the right direction relative to coordination of your protection.
I think it's all about point of connection on the installation. So if you think about you need to maintain selectivity downstream of an installation, whatever your battery system or alternate system is, it would need to switch in so that you don't have to worry about any sort of backward selectivity. So at the moment, I think solar, we just plug it into the existing board via a breaker to feed in. Whether or not we still do that, would it be just something that switches in on the mains, on the tails somewhere into a device? Static switch maybe on the main tails, possibly.
Solar's not too bad because solar's only one direction. The real problem occurs with storage batteries, because you can charge up the batteries,
and then of course
you're discharging them, and it is literally in the opposite direction. So, yeah,
I don't know what the answer is there. Be interesting to see how that develops.
Yeah. And the final point on this particular bit is 867, which is testing and verification. Loop impedance test instruments may not work properly with inverters, or for that matter, say solar inverters or battery systems or whatever else. So it's suggesting alternative methods of determining loop impedance and fault current should be used.
Oh.
And there are test kits you can buy for solar strings, solar systems. They are about 3,500 of the Queen's pounds, the one that I have. But yeah, they're not cheap.
Problem with that wording is alternative will just be an immediate cheap method of saying just calculate it. It's a coward. It's a coward way of writing that.
Of course it is. On initial verification, that should not be allowed calculating at all.
No,
absolutely not.
So
there's
a lot of work needs doing on testing.
And again, it doesn't give you any suggestions about how you would calculate it or what you should do instead. It's just, here's something else to consider, and
why would it?
Go away and think about it, sort of thing. But yeah, it's certainly the case that certain loop impedance testers don't work very well or in expected ways if they have a solar inverter connected, because I've seen that myself.
What happens with the instrument, just in case people are wondering?
Well, in the case of this one, which was unfortunately when the assessor person for the Part P scheme was coming around to have a look, it was an installation we got, which I'd obviously previously tested with it. And basically, when the solar was switched off and disconnected, you got the expected results of something like sort of 1.1 ohms or something, say. When the solar inverter was switched on and was feeding into the system, this particular test equipment was reading something like 5-6 ohms, which was, of course, complete nonsense. Purely for the fact that the solar was feeding into the system whilst this was trying to obviously do its measurements at the other end. So that was an older piece of equipment. Obviously, whether new ones are better, some probably are, but it's definitely something to be aware of if you've got multiple sources of supply.
Well, the Mega MFT has that confidence thing that they've said will work on inverters, but it will never 100% align, I don't think.
Yeah, I mean, this was an older one, which was not a Mega, it was another manufacturer. We won't mention the manufacturer because it's probably not their fault, but yeah, definitely if you've got several sources of supply coming in, it's almost inevitable there's going to be some kind of differences between what you're actually measuring and what you're getting. So,
indeed.
And again, in different modes, it could be actually a different measurement anyhow. So if you're off grid and on your island mode, loop impedance is definitely going to be different from what you would measure whilst connected to the grid. So it maybe you have to test it in all three modes, which means a lot more testing and a lot more writing.
It is a bit alarming, though, because if you're going to start measuring fault currents, you're going to basically be using the same test strategy with a little bit of Ohm's law adjustment.
Yeah.
So, interesting.
Right, next bit.
So the final bit on this one of the annexes, not a whole lot to really see here, but there's 4 of them, A, B, C, and D, which is A82. A82 is the objectives and concept, basically covers what we've just covered. B82 is operating modes. There's got some decent diagrams there which give you examples of where the additional energy flows will go in the various directions, so worth having a look there. C82 is interaction with the public network, and it basically repeats go and look at the Decode website about 8 times in a row.
It does, doesn't it?
And D82 is quite extensive. It gives you a whole load of examples, again with diagrams of various types of prosumer electrical installation and how this electrical energy management system could fit into that. On most of those, they've shown the EMS as a big block of stuff with sort of tendrils going out to bits of the installation, but I think in reality it's going to be several pieces of separate equipment, like your vehicle charger and the smart meter and your smart refrigerator and whatever else, which all then connect together and communicate in various ways to achieve the end result.
You can get washing machines that will email you now.
Yeah.
You know that you can buy a washing machine that's got Internet of Things enabled, and it will email you and work on apps. And
yeah, and the refrigerator and the freezer things is quite interesting, because if they say there was a shortage of power on the grid, a really easy way to reduce the load is to turn off fridges and freezers. Because if you turn your fridge off, it's not going to suddenly defrost in 6 seconds. It's probably fine for half an hour. So if you had, say, 1 million fridges in the UK turn off, that's probably solve your problem with.
But John, again, I'm going to refer back to Mr. Skirm, who is the druid, the wizard, fountain of all knowledge. we are mitigating for mass aging failures on a national grid potentially. I know there's the argument of it's smart and we're producing and generating, and then the grid has to adapt and evolve. But what scares most people is the thought that you could have your installations remotely controlled to protect the grid.
I think
that's a scary secondary impact, isn't it?
And I think this is the thing. This is the problem with not bringing Chapter 81 in as well.
Yeah.
If you bring Chapter 81 in with this, then you've got a much larger argument with regards to economic.
Yeah.
And a lot of that leads to this. Like you just said, if we thought about rewiring a house and having a dedicated radial circuit that went from a control system to the refrigerator, and then the management system knew exactly which cable to turn off for an hour or two to turn back on. If we have that on a ring final circuit, we don't have that control. You see, but if we had systems wired in that, we had this chat with Louise when she came on about smart homes with lighting and things. If we started wiring homes in that fashion, where everything was just going off in one direction from one point to one point, instead of having things in a in a radial arrangement, and we told this machine, this cable does the fridge, this cable does the microwave, then in the future that could be a lot more economically stable, and it can also help the grid. It's just a case of evolving the way we install systems. It might be that manufacturers will create this technology which will force our hand. They'll say, yes, this works, but you must install it this way. And if they brought 81 in with this 82, then that would be a lot more easier to basically convince the industry. Because just with 82, we're thinking like Mr. Skirm does, that we're really just kind of we're polishing someone else's turd here.
And for those listening who don't know what reference to Louise is, because I don't know whether these will be out, I don't know if her podcast will be out. There's a lady called Louise Tarling. She's without a doubt the queen of smart homes. Does amazing work on Instagram. Workmanship is off the charts. Thought, diligence. The profile was fantastic.
She's one of our. We're doing a series, aren't we? With ladies,
as part of this series of podcasts, it's pretty much earthing and bonding technical. These are the extra ones we've slotted in post Amendment 2, and we've got some fantastic ladies from across the industry in this series. Louise is one of them, but I don't know if it will be out because I've just kind of put them in YouTube and scheduled them, so I need to check. But stay tuned if it isn't already out for Louise to talk about smart homes. Amazing woman, absolutely amazing woman. So anyway, right, is that kind of part 8? Are we?
That is the end of what was in it, yeah. So
did you guys cover part 6, appendix, the model forms and stuff? You've done that?
We did indeed, sir. We went through incredible detail.
And you covered the new appendix for labelling?
We covered the labelling in general, yes.
You mentioned it?
Yeah, we went through it.
I don't think there's anything else in, is there?
Not really. I think we've done 4 hours now on Amendment 2, and I think that's pretty good going considering we've done 5 hours of webinars, 4 hours of podcasts within a week of the document.
Well, the next thing for us to do though is investigate things in more detail, and then we can do a dedicated podcast on solar, on this and on this.
I think definitely,
as we wait for the industry to start to speak up for itself about this.
So let me call in a favour for solar, because I have been chasing someone to talk about solar with me. I will mug him and get him in as a December special, because I really do want to get these kind of wrapped up for Christmas time so that we've got a nice break in the new year. And yeah, we'll see what we can get. So we'll try and get something on solar before the end of the year. We've got some amazing earthing stuff still coming up. We've got some amazing ladies still coming up. And yeah, that's pretty much it, gents. Any quick final thoughts?
Yeah, I'll just put one in that this whole idea of the smart grid is to basically use the cables we've got in a more sensible way. So you're sort of, instead of having a huge peak load at sort of 5 minutes of the day, you're spreading that load out over the course of a day, which then avoids the need to put in huge, massive cables to every house in Britain, which of course is going to be massively expensive. So it's about using your existing infrastructure in a more sensible way, rather than just say having a massive load at peak times and nothing at the rest of it.
Perfectly worded. Can't argue with that. Thank you, JW. Dave?
There's loads of thoughts, mate. It's early. We've got a year. We've got a year for them to play around with this, and then to give us more information as to what is going to be brought out. I think definitely with what we just said about the reporting, there needs to be an amendment to a draft or another alternative or something, or an extension. I don't know.
I don't know how it works. All I know is
but-
there's lots of new regs, lots of tweaks, few minor
think-
errors, bit of slapdash here and there.
I think though, I mean, we've been drilling into electricians, but the idea of trying to think a bit more positively about trying to level up. If you've been spending the last 12 months or so listening to these podcasts and trying to expand your mind and just open up a bit more about what the industry can do, then you're going to be fine. If you really are just sticking with rings, radials, and lights and stuff, you're really going to be struggling when this stuff comes through. So you really need to get on board with the idea of just thinking about doing things differently in the future.
And it's a valid point.
If you don't think about doing things differently, you're going to really struggle. And the point of this is to try to talk about these things now so we can prepare ourselves and not wait for the industry to tell us to do it differently.
Yeah. And it's fair to say we're developing that knowledge as well.
Oh, yeah, definitely.
Yeah, the important thing here is that although some of these changes may not come in this particular amendment, they're going to arrive at some point. They're not going to just disappear and go away. It's inevitable they're going to show up. So whether it's in a year or two's time or whether it's in 3 or 4 years' time, they will be arriving, and there's going to be a lot more stuff to go with it as well.
And I think it's important to say as well, generationally, there will always be, for the rest of my career, there will always be a person in a home who wants just the rings, the radials, and that's it. The trouble is with the emerging technology, it's going to get more and more difficult for those people to do that successfully and in a compliant manner.
Yes.
And this is where leveling up and being able to make those informed. I mean, I'm rewiring my house for radials at the moment into Type A RCBOs. I think that will do me for the next 10, 15 years. But I do want to I have plans to put solar on my roof, and battery storage I think would be essential. When that day comes, I'm ripping that board out. So I already know that the board I'm installing has a life of 15 years, tops.
Yeah.
And I've got to change it again. So I'm going to try and future-proof as much as I can with that.
And the flip side of this is obviously the homeowner. We hear lots of people moan about homeowners, and there's lots of negativity with regards to electricians and stuff. And the homeowners need to learn along with us. And homeowners are going to get to the point where they're going to ask why things are now more expensive or why now things are more complicated. And we want to kind of talk about this. With you guys, so that we can all get ourselves on the right level of understanding, so we can actually, not just moan about it to homeowners when these things come in a few years. Take for example the AFDD. We know where that's gonna. We know what the agenda was. Oh, a year ago we knew what was going to happen because we looked at 603, 604. We looked at other countries. So we've got to start thinking now about how to properly talk to homeowners and clients when it does become a problem, when it does mean I have to depart from the regulations to not install this device now. We don't want to get to that point, so we need to make sure we can gain, regain some confidence in this technology. Yes, it costs. Sometimes, the question is, should it now cost more, or maybe they shouldn't have been so cheap? Some of these things and some of these methods, Maybe we shouldn't have gone so low in our standards, so low in the way that we can just sell equipment to the public wherever.
I think it's also worth noting, I suppose, on a final thought, that if you're wondering why we referenced earlier on the code of practice for the in-service inspection of electrical equipment, just going back to 60364 part 1, it refers to an additional special occasion which isn't in the regs, which is furniture.
Yeah, electrical equipment in furniture.
Which kind of aligns with this fixed whole pattern. We've got to change the way we think. Electrical installations are in furniture now. How many couches you can buy with USB socket chargers built in?
Pop-up sockets in the kitchen.
Indeed.
Yeah.
So the future's bright. The future's orange. I know that's a mobile phone company that doesn't exist anymore. There's opportunities there. I'm going to say this, and I think I've said it in earlier podcasts. The industry bodies need to do more. Whatever they think they're doing, they need to do more, not only to help Sparks, but to seriously convince the homeowners this is coming. Don't allow a good contractor who's doing an ethical and honest and hard day's work to try to comply with the intent of these regulations get priced out by a cowboy wearing a similar badge or registration who will just want to do it cheaper and be damned with it. So I think there's the industry has to level up. The industry bodies have got to level up as well. And I think the best thing you can do is winning over the hearts and minds of consumers and homeowners and producing documents to say this is what to expect from your electrical installations. They're not ripping you off. And if you're going with someone who's doing this, they are ripping you off.
It's a valid point. I mean, we've had this, we've had a lot of examples of them kind of not committing to a response, being a bit loose, being a bit flaky. They need to write down their expectations of their
strategy.
members.
They need to have a strategy going forward.
We expect our members to do this. They need to write that down. They need to write that down, and then the public can have that, and the public can consider that.
It is definitely exciting times. It is nothing boring about where this industry is going at the moment. It is the most fluidic industry. And I'll tell you who the second most fluidic are, and that is the gas guys, because they're not allowed to install boilers after 2025, gas ones. So they are going to have to diversify their knowledge. And knowing the gas industry like we do, some of the guys, they'll roll up their sleeves and they'll just dive straight into, leveling up their skills and adapting and converting, and because it's their bread and butter. And I think we as an industry can do that a lot better than what we currently do. So yeah, that's really it, guys. Thank you very much for this 4-hour marathon. And to those who are listening, sorry if we bored you. Thank you very much for listening. It's always appreciated if this helps. Every minute has been worth it. And until the next podcast, take care of yourself and each other. Bye-bye.
See ya.
Right.